Welcome to Mathematical Concepts. My name is Freddy, and in today's video we are continuing from the previous video, which we introduced nonlinear inequalities, and we have explained, introduced, scrutinized thoroughly the chapter nonlinear inequalities. This is in your grade 11 and 12 mathematics. So in today's video we are going to be jumping straight into examples. So without further waste of time, let's get to it. There are two things that was written on the board in the previous video when we introduced nonlinear inequalities, but then they were not verbalized. So one of them was that in linear inequalities or in inequalities, we do not multiply with a factor of which the sign is unknown. We do not multiply with a variable of which the sign is unknown. So if you have x or any variable, but you don't know whether it is negative or positive, you then do not multiply with that factor or that variable or that term. The reason for that is if you multiply an inequality with a negative variable, then your sign must change. If you multiply this by -1, you multiply the other side by -1, your sign must change from a greater to a less than. Now, if you have a variable of which you do not know the sign, you will not be able to know whether you must keep the sign the same or change it. So that is the reason why we do not multiply with a variable or a number or a factor of which we do not know the sign of. That is one. And in fractions, I just want to emphasize that in fractions you ensure that your x is not, your denominator is not 0. Therefore, x in this case cannot be equal to the number 3, because if our x is equal to the number 3, then we have 3 minus 3, which is 0, and then we therefore dividing by 0, and therefore the expression divided by 0 becomes undefined. So keep those two in mind. And the one last thing that I would like to emphasize in linear in inequalities is that we are guarding the expression such that the sign is observed and respected, meaning whatever we do in our computation of the expression, we ensure that whatever value of x we say this value of x is, it is such that when substituted into the expression, the entire expression remains greater or equals to 0, or it respects the sign. Okay, I hope that is clear. Now, how do we go about solving this nonlinear inequality that is presented to us? Like I mentioned in the previous video, the first step is you put your expression in standard form. That is, the 0 must be on the right, on the entire expression must be on the left, or vice versa. As long as you have a 0 on one side, then your equation, your expression or equation is in standard form. We say it is in standard form. Then the following step will be to factorize. Okay, it will be to factorize. Now, when you factorize in fractions of inequalities, you factorize the numerator separate from the denominator. All right, the numerator is factorized separate from the denominator, and in this case our expression is already factorized, and then we have factors. We have 3 factors. We have this factor, we have this factor, we have this factor. Now, when I talk of factors, that will be what I'm referring to. Okay. Now, then we test our factors, not the expression. We're testing our factors. Which a value of x are our factors satisfying the sign? The greater is equal to or the less, whatever sign will be having. Now, to test this, you look for the values of x for which the factor is equal to 0, because now you have 0 on the right side. Okay, so now let's start with the first factor. The first factor is 2x plus 1. All right, if you look at this factor, if you say this is equals to 0, if you're looking for the value of x for which this factor is equal to 0, then you are going to equate this factor to 0, and then your 2x will be equals to -1, and your x will be a -half. Okay, if you have this one, the second factor, your value is going to be what? 1, the x value, because 1 minus 1 is 0. In this one, if you say 2 times a -half, you're going to have a -1. A -1 plus 1 is 0. Now, in this one, it goes without saying that you have a +3. The reason why is a 3 minus a +3 gives you 0. So, therefore, you are having these values that you're going to use to test your factors. Each of your factors, okay, those are the values that you're going to be using. Let me write them here: -half, 1, +3. Okay, reasons, I want to write them here so that we don't forget them. Okay, all right. So now what you're going to do is you're going to make a number line like that for testing. You're going to have 3 values. You're going to have a +3 there. You're going to have a +1 there. Okay. You're going to have a -half here. All right. And then on this side of a -1, before, okay, let me not confuse you. So we are going to make these dotted lines on your values. You're going to make the dotted lines on your values to partition them. Okay, now you are going to test your factors. The first factor that you have is 2x plus 1. Walk with me. The second one is x minus 1. The third one is 3 minus x. Okay, 3 minus x. You have 3 factors now. You have 3 factors now. Okay, all right. Now I want you guys to look at this. On this side of +3, you're gonna have a +4. Okay, on this side of -half, you're gonna have -1, -2, so on and so forth. All right, so now the reason why you write this is you're gonna be using these values. So on this side, if your x is -1, what happens to this expression? -1 times 2 is -2. -2 plus 1 is -1. So this factor becomes negative. If you put -1 here, -1 minus 1 becomes -2. This factor is negative. If you put -1 here, 3 minus 1 becomes positive. This factor is positive on this side. Okay, let's come to this side. So between a half and a +1, you could have a 0 here. Okay, you could have a 0. So if you're going to put 3 minus 0, you'll have a positive 3. So this factor will be positive here. If you're going to have x minus 1 and you put x for 0, right? Then 0 minus 1 becomes negative 1. The factor is negative. If you're going to put 0 here, 3 minus 0 becomes positive 3. Therefore, you have positive here. Walk with me now. Okay. Now, on this side, between a positive 1 and a positive 3, you could have a positive 2. All right. Now, for a positive 2, you're going to do the same thing. 2 times 2 here will be 4. 4 plus 1 is 5. So this factor will be positive in this side. And then 2 minus 1 is positive 1. Therefore, this is positive. 3 minus 2 will be positive 1. Okay. 3 minus into positive 2, that will be a positive 1. Therefore, this is still positive. In this side, all of them are positive. Okay. Now, you're coming this side. If you put 4, 2 times 4 plus 1 is still positive. Therefore, this is positive on this side. 4 minus 1 is positive, right? Still positive. 3 minus 4, that will be negative. Okay, so this will be negative. All right, 3 minus 4, it will be negative. Okay, now back to your expression. Your expression says this times that divided by this is greater or equal to 0. Okay, so now you're going to do the same. You're going to say this factor multiplied by this factor divided by this. Because it's this times this divided by this. The sign of this and the sign of that, the sign of this times the sign of that divided by the sign of this. So you have a positive times positive. You have negative times negative. It's going to give you a positive. A positive divided by a positive is a positive. So the whole expression is positive in this side. All right, walk with me. Walk with me. We have found the signs of these factors, but we are saying this times this divided by that. So hence we are saying minus times minus divided by positive. We are going to do the same throughout. Positive times negative becomes negative. Negative divided by positive is still negative. Okay, so then this expression is negative here. Right. Positive multiplied by positive is positive. Divided by positive remains positive. Walk with me here. Okay. All right. Now, positive times positive is positive. Divided by negative, it remains negative. Okay. All right. So now we know our expression is positive this side, negative, positive, negative. Okay. Now, but our expression must always be greater or equals to 0. Must be bigger than 0. If it's bigger than 0, it means it's positive. It's not negative. So it means this is not our answer. Our answer is only where our expression is positive. Our answer lies only where the expression is positive. Okay? All right. Walk with me. Walk with me. Now, what this implies? It implies that our answer is here. Okay, now before we come here, when we start, I mentioned to you that x cannot be equals to 3, because 3 minus 3 is 0, therefore the expression will be undefined. So we cannot equate x to be 3. Just keep that in mind, right? But now we have found where the value of x is. So we are going to say, let me just make a small line in a box here. We are going to say our x, right, is this side, okay, is less than half. All right, it's not bigger, because once it becomes bigger than half, then the expression becomes negative, but the sign tells us that our expression is actually bigger than 0, and anything bigger than 0 must be positive. So our x is less than negative half, but it can still be equal to negative half, no problem, because then it becomes 0. All right, because if it's negative half times 2 is negative 1. Negative 1 plus 1 is 0. 0 times 0 is 0. 0 divided by this is not undefined. It is still 0. So, and then we have this equal to 0. So it is okay to have x being equal to negative half. But x is less than negative half. Okay? All right? Now, our x is not here. Our x is here. Now, then we say again, our x is greater than 1. All right? It can still be equal to 1. For the same reason, 1 minus 1 is 0. 0 times this is 0. And then 0 divided by that is 0. For the same reason. Okay. So our x is equal to 1 or bigger, but our x is less than 3. We cannot say it is equal, because if it becomes equal, we have this situation here. It can be equal here, it can be equal here, but it cannot be equal in the denominator because it's gonna be undefined. So this is your answer. So in your answer, the first answer you're gonna have, you're gonna say x is not equals to 3. Okay, that is your first answer. Your second answer, x is less or greater than, no, is less or equals to negative half, is greater or equals to 1, and then is less than 3. All right, that is your answer. Okay, I hope it is clear. All right, I hope that it is clear. Now we are going to the second example. I'm going to just wrap this in the interest of having space to write on clarity. So we are going to do a similar thing, but not the same thing, because our problems are not the same. Okay, our problems are not the same. Now please walk with me until we finish all these examples, because in each of them there is a lesson to be learned. There is a lesson to be learned, because they are not the same and therefore require different attention. They're very tricky. Now, on this one, x squared plus 2 divided by 2 minus x is greater than 0. The first thing that you notice is that x is not equals to 2, because if x is equals to 2, you have 2 minus 2, and then your denominator becomes negative. You cannot divide by negative. Okay, so you'll get a mark for the first answer. Now, our expression, the whole of our expression is positive. According to our sign, it is bigger than 0. It's greater than 0. So we are going to find the value of x such that this expression is always bigger than 0. So because we need to satisfy that. Okay, we need to satisfy that. Now walk with me. For x squared plus 1, whatever value of x you put for x in the numerator, your expression will always be positive. Whether you put a negative 100 or you put 0 or you put whatever, because of the square root, whatever value is the same as absolute value. Whatever value you put in there is going to be positive. And then a positive value and a positive value will always be greater than 0. Okay, so you do not worry yourself with that. Your second answer, you'll just write x squared plus 2 is greater than 0 for any value of x. Okay, for any value of x, x squared plus 2 will always be greater than 0. Alright, I hope it's clear. Even if you put 0, 0 squared is 0 plus 2 is positive. Negative 5 squared is 25. 25 plus 2 is greater than 0. Positive throughout. Okay, alright. Now, it means that the only value you're going to concern yourself with is the denominator, which is 2 minus x. If your value of the numerator is positive, once you divide it with a negative, if this factor here is negative, then the whole expression becomes negative. Then negative becomes no longer greater than 0. So it means this must be greater than 0. Whatever value you get here must be greater than 0. Alright, so therefore what you do is you are just going to take this positive 2 to the other side, and then it's gonna be negative. So you remain with minus x is greater than minus 2. Okay, and then you divide here by a negative 1, you divide here by a negative 1, because we know this with the sign that we are dividing by, right? Therefore, the sign is going to change because we are dividing by a negative, guys, right? This is not a variable. We know what the sign here is. The sign here is negative. So negative divided by negative will be a positive x. But this x will no longer be greater, will be less. Okay. Positive times positive. Positive divided by positive is, negative. Sorry guys, negative divided by negative is positive. 2 divided by 1 is 2. Therefore, your answer is x is less than 2. Okay. That is your answer there. The sign only changed here to there because we divided by a negative. Get the basics. Remember I said each and every problem here present a different challenge and a different angle, and it reveals a different a lesson. So this is one of those. In this one we learned that if this is positive, then we do not have to worry ourselves with. We look at the one below and we know that x cannot be equal to 0 for the obvious reason that this expression will be undefined. And then we now concern ourselves with this because this must be positive, because positive divided by positive is greater than 0. But if we have x being equal to 0, to 2, then we have undefined. Okay, so now we take this only, we say this is greater than 0, then we take this 2 across, it's a positive this side, it's going to be negative this side, and then the sign is still the same. We multiply by negative, we divide by -1, or we multiply by negative, and then we get a positive x, and then the sign changes because we multiply by positive, and then our final answer is x is less than 2. Now let's see that. What is less than 2? 0 is less than 2. Okay, 2 minus 0 is a positive 2, bigger than 0. 1 is still less than 2. 2 minus 1 is 1. The positive divided by positive 1 is the, but then the problem becomes when 2 gets to the value of 2. I mean, x gets to the value of 2. You see, like that. So I'm gonna go ahead and wrap this. I hope that you were able to get it. In the interest of time and cleanliness, I'm gonna remove this. You can always rewatch the video or pause the video there if you did not understand or if you wanted to see something. Okay, right, so we are moving to this one. Now this one is a reminder that of step 1, to have your expression in standard form. You can immediately see that this is not in standard form. So the first number 1 in the previous video, number 1 says put this in standard form. Okay, let me just draw a line here. Okay, and take this expression up there. So 5x plus 1 divided by x minus 2 is greater or equals to 2. Okay, I'm gonna remove it here because I'm gonna need a little bit of space. Okay, so the first thing is you recognize that this is not in standard form. So you're going to put it in standard form. You're gonna have 5x plus 1 over x minus 2. I hope that it was 1, guys. I don't remember. And then you're gonna take, let's just assume it's 1 anyway. You're gonna take this 2 across. Then it's gonna be -2 is greater or equal to 0. Okay, all right. So now you have your equation in standard form. This is number 1. You have observed number 1. So number 2 in the previous video says if you have 2 fractions, make them 1 fraction. Okay, if you remember number 2, go visit the previous video. Number 2 says that. So now we have 2 fractions because -2 is over 1. Anything divided by 1 is that thing. So now it means that we are going to use the lowest common denominator to get the value, to get these 2 fractions into 1 fraction. So we're going to take the lowest common denominator, which is x minus 2. Now x minus 2 into x minus 2 goes once. 1 times 5x plus 1 is 5x plus 1. Okay, and then we bring that sign here, negative. 1 into x minus 2 goes x minus 2. Now x minus 2 times 2, you get minus 2 into x minus 2. Okay, like that. All right, is greater or equals to 0. All right, now I'm going to simplify that. You're going to have 5x plus 1 minus 2x plus 4 is over x minus 2 is greater or equal to 0. Okay, and then you're gonna have these and these. 5x minus 2x, you remain with 3x, and then positive 1 and a positive 4 is positive 5 over x minus 2 is greater or equals to 0. So it brings you to this. Okay, it brings you to this. Okay, it brings you to that. Now you have your expression in standard form, and then you have your factors. So these are what you're now going to test out. Okay, these are now what you're going to test out. Let me take this up because I'm gonna want to use this space. So this is 2 minus x over x squared minus 2 is greater than 1. All right, let me just do that. Okay, I'm going to use this space. Okay, cool. So now you are going to find the factors, the value of x for which the expression is equals to 0. So you have 3x plus 5 is equals to 0. Therefore, you have 3x is equals to negative 5. You have x is equals to negative 5 over 3. Okay, 5 over 3. Now 3 into 5 goes once, and it leaves what? It leaves 2 over 3. Okay, so 1 you're gonna have which is also equals to a negative 1 and 2 over 3. Okay, all right, and then this will be negative 1.0. If you want to put it in decimal, it will be negative 1.0 because 3 into 2 goes 0 times. And then if you bring that 0 here, 3 into 20, if you divide 20 by 3, in 10 you'll have 3, in another 10 you'll have 3, so you'll have 6, and then you're going to leave 4, 2 and 1 and 1, you're going to leave 2. So you're going to have 3 and 3, which is 6, and yeah, so you can leave it at that, 1.06. Okay, that will be 1.06. All right, if you have a calculator. I don't have a calculator. So then here you will have x is equals to 2, because 2 minus 2 is 0. Okay, so these are your two values that you're going to investigate. But remember, x cannot be equal to 2. X cannot be equal to 2 because of this denominator. Okay, so for our first answer will be that x is not equals to 2. Here is because we're just looking for the values at which we are going to test our expression. Now we are going to just do our number line there, and we are having two values. Let's say we have our positive 2 here, and then we have our negative 1.06 here, and then let's say here we'll be having a negative 2, and then here we'll be having a positive 3, and somewhere we'll be having a 0, but our values are this. This is our values. That's where we're gonna make the dotted lines, our two values. Okay, and then what are we testing? We are testing 3x plus 5 as a factor, 3x plus 5 as a factor, and then we are testing x minus 2 as a factor. Okay, so we are going to say on this side of our numbers, these are our numbers. On this side we have a negative 1.06. So if we put x is equals to negative 2, we're gonna have negative 6 plus 5, which is negative. Okay, if we put negative 2 here, we're gonna have negative 2 and negative 2, which is negative 4. Okay, come in this side. If we put x is 0, we're gonna have a 0 plus 5, which is positive. If we put 0 minus 2, we're gonna have negative. Okay, right. If we put 3 on this side, if we put 3, 3 times 3 is 9, 9 plus 5 is 14, which is a positive 14. 3 minus 2 is positive 1. Okay, now coming back to our factors, is this divided by that? Okay, so it is this divided by that. So negative divided by negative is positive. Okay, it's positive. Positive divided by negative is negative. And then positive divided by positive is positive. Now we are coming back to our sign. Our sign is greater, is equal or greater than 0. So now this means that while this expression must be positive. Now where is our expression positive? Is positive here and positive there. Meaning our x doesn't lie here. It only lies here and here. So now for our answer, we are going to say the first, let me write my answer here. I'm going to start by saying x is not equals to 2 because of this, because of that. Okay, right, that is answer number 1. There is your mark. The second mark will be saying x is the sign. Okay, so x is less, right? X is less then is less than minus 5 over 3, which is 1.06. X is less than that. It is the sign of the negative side of the x values in a Cartesian plane. And then another one is this side. Our x is greater than 2. Okay, positive 2. Those are our answers. Okay, now why can't we say x is less or equals to this, but we only saying it's less? The reason is, if we say it's equal to this, okay, then we're gonna have this as 0. 0 divided by that is going to be 0. Therefore, this is still satisfactory because we have 0 that side. So we can also say equal. Alright, but here we can't say equal. Why? Because if it's equal, then it becomes undefined. So these are our 3 answers. Okay. Alright, I know the board looks very messy, but if you're following, you should be able to understand by now, especially if you started with us on the first video. So if I were to break it in short, you have the first thing. You notice that the expression is not in standard form. You take this 2 to the side, now you have it in standard form. And then number 2, this is number 1 satisfied. Number 2 says, if you have 2 fractions, then you must make it 1 fraction. 2 is a fraction because 2 divided by 1 is a fraction. Then you take the lowest common denominator, which is x minus 2 here, and then you use the LCM method, and then you get this into 1 fraction, which we did here up until here. Alright, x minus 2 into x minus 2 goes once. 1 times 5x plus 1 is 5x plus 1, which you put there, and then you take this negative down. 1 into x minus 2 becomes x minus 2, then x minus 2 there times x minus 2 here, you get 5x plus 1 minus 2x plus 4, and then you work it, you add this and that, and then you add this and that, and then you get 3x plus 5 over x minus 2 is greater or equal to 0, and then from there you find the values for which this expression is 0. That is, for 3x plus 5 is 5 over negative 5 over 3, and then which is this number, you put it there for testing, and then this is 2 minus 2 is 0, and then you put it there for testing, and then you take your two factors, okay, you plug them here. You test, and then because you have this divided by that, you're going to take this divided by that and say negative divided by negative is positive. Positive divided by negative is negative. Positive divided by positive is positive. And then you're going to come back and say my x is bigger or equals to 0, meaning that my answer must be positive. And then you have positive here, you have positive, then your x is here. It's not here. Okay, so then you come and you write this x is not equals to 2 because of that, and then x is less or equals because x is this side, is less. This side where your expression is positive, x is less than negative 1.06, and then also on that side where it's greater than positive 2. Okay, I'm just gonna go ahead and remove this, guys, so that we can have space for the next expression, okay, which is this one. I hope that you are working with me and that you are actually learning, and that each and every example that we do is actually taking you a step closer to master your inequalities. In this section, we are looking at nonlinear inequalities. Nonlinear inequalities are equalities of which the formula is not of the first degree. Remember your straight line graph, your x is having an exponent of the first degree. Once you have x squared, then you're no longer having a linear, meaning a straight line. It's no longer a straight line. It's either a parabola. So this is not linear. That's what they mean when they say non-linear. Okay, so we are almost there, guys. We are almost there. And in this video, we are actually just punching inequalities. So we are on the fourth one now, which is this one. Okay, now they say this expression must be bigger than 1. Okay, like I explained before, if the expression is not in standard form, the first thing that you must do, you must put it in standard form. You have 2 minus x over x squared minus 2 is greater than 1. So the first thing that we're going to do, we're going to put it in standard form. 2, so which is 2 minus x over x squared minus 2 minus 1 is greater or equal to 0. Now this is in standard form, okay? And then your minus 1 is over 1. We have fractions, so we're going to make this one fraction, okay? So you're going to have your LCM is going to be x squared minus 2, all right? And then you're going to have x squared minus 2 into this goes once. 1 times that is 2 minus x, and then 1 into that is you put this negative here, and then 1 into that negative 1, put it there. 1 into this goes x squared minus 2 times, then you're going to say minus 1 times x squared minus 2 is greater or equals, no, not equal. Remember, we started with only greater, so it is greater than 0, okay? So you're going to have 2 minus x squared plus 2 over x squared minus 2 is greater than 0. Okay, let me take it here. Let me take it here. So I'm going to take this here so that we can work with it nicely. So I'm going to start with minus x squared. All right, minus x squared minus x squared minus x. 2 plus 2 is 4 plus 4 all over x squared minus 2 is greater than 0. Okay, so I'm going to multiply everything or you can either multiply the whole thing with a negative, okay, but you're gonna have a negative this side, okay, or you can just factorize the negative out, okay. So you can have minus 1 into, because if you multiply you're gonna have to change the sign. So let's try not multiplying but factoring the negative out, because we want to get our x squared to be positive so that we can factorize it. So we have minus into x squared plus x minus 4 all over x squared minus 2 is greater than 0. Okay. Then, if we were to factorize the top part, we will have minus 1 into x. Okay, we're gonna look for the factors of 4 that will give us positive 1. Okay, so for the factors of 4, we have 1 times 4 and 2 times 2. Okay, so but we are looking to get 1 here. Okay, so we need to factorize this accordingly. So I'm thinking that if we have 2 and 2, we're not gonna get a positive there. So one might resort to using the quadratic equation there. Okay, and then this side, if we let's see if we can be able to take it back. If we can't factorize it further, let's look at it from the beginning. Maybe we missed something from the beginning. Okay, can we factorize x squared minus 2 before we go any further? Can we do that? Let's try. Let's try quickly. Okay, they can be tricky at times. Let's try. Okay, so as always, the first step will be, let me remove this. We'll come back to it. Let's check where we missed a step. So the first step, as always, will be to remove the 1 from this side to get our equation in standard form. Okay, minus 1 is greater or equal to 0, which is like that. Now, I want to see if we can't factorize this before we go any further. Okay, guys? All right. So, if we were to factorize this, if we were to have 2 brackets, because this is equation of second degree, and we have x here, okay? And then we have 2 and 2. Okay, we're still not gonna get it. We are still not gonna get it, guys. So let's look at it and see what is it that we are missing. Okay, so the second step is to make this one fraction. Let's see. As we did, we had x squared minus 2. I'm busy thinking of the factors for this. So x minus 2 into that will be this, and then 1. So that will be x squared minus 2 into x squared minus 2 goes once. 1 times 2 minus x is 2 minus x. Okay, and then 1 into x squared minus 2 goes x squared minus 2 times. X squared minus 2 times minus 1 becomes negative x squared positive 2 is greater or equal to 0. Okay, therefore now we can now have this as come this side, minus x squared minus x plus 4 squared minus 2. I see where we didn't go right with it. Okay, still greater. Now, if we say negative x into x negative x into x minus plus 1 plus 4. Okay, over x squared minus 2 is greater than 0. Okay, alright. I will be cutting this video until this expression. Okay, alright. I will actually go look for how to actually solve this, guys, and I will get back to you.